And people who watch routers and watch the network, in fact, are aware that a whole lot of the infrastructure gets owned pretty easily. Does everybody here understand what's meant by owned? Right? That means somebody, not you, controls your resources and your network and can do whatever they want with it, which probably isn't what you want with it or your customers want with it. So we have 3 panels today. The first one's Rob Thomas in his usual evangelical style that will be somewhat cramped by his not having a radio mic, so he actually has to stand fairly still. Oh, you got one. Okay. Whew. Okay, hope everybody's lunch is firmly seated. Rob's purpose is to scare you with the extent to which your resources are or can be owned by miscreants. Then Neal Ziring of NSA will explain to you what you can do with your current routers to act responsibly and keep the problems down. And then George Jones, MITRE, will tell you about work that's going on, he's doing, leading in the ITF, to produce best current practices for router vendors, for equipment vendors, to enable us to run more secure networks by putting the features we need in those routers. Okay? And I think we have a lot of time. And so I suggest, if you want to argue or you have questions or so, just kind of do it, and then we'll throw in the normal question periods. And in the meantime, Rob and Susan are trying to figure out how to do this.
Function 8, right?
It's the button over there.
7.
No signal.
Yeah.
What's that say?
Turn it back up to A.
Should be on A or B, Jeff?
A says speaker.
Speaker laptop, A.
No, it should be on B then. This isn't a speaker laptop.
No,
Well, but
try
it's
A.
the same chord. Okay.
No.
Yep, there it is.
Yes, but it works.
Thanks, man.
Hi, Nanog. Hi, Rob. Hi, Nanog.
Hi, Rob!
What a crowd, what a
you,
crowd.
didn't I?
My name is Rob Thomas. I'm with Team Cymru, but Cisco pays my salary. If you like what I do and if you like what Team Cymru does, please hug your Cisco rep. They'll appreciate it. I'm going to talk today.
Excuse me. I don't want to hug a Cisco rep.
What I'm going to talk about today is what leads up to the owned status of many of your routers. So I'm going to talk about all the bad stuff. Now, Randy says I'm going to scare you a little bit. I actually am not setting out to scare you, but I hope it does shock you a little bit. I hope it makes you realize how ubiquitous this problem really has become. And by the way, how long it's been going on. That's the part that's probably going to scare you a little bit. Next slide, please. So, my caffeinated commentary for today, I'm going to talk about in the beginning. Where did this start? Why did people start owning routers? What benefit do they get from that? I'm going to talk about no lazy Ciscos. How many of you have Cisco routers that have 50% CPU or less? Yeah, the miscreants love you. Motives of the modern miscreant. Why do they do this? As we talk about why you should secure this stuff, it's all about resource allocation. Go to your management, hey, I need time to secure the routers. Why? So I'm going to help you answer that question. And then, it's true I never shut up, but I will try to give some final thoughts to you. Randy has kindly given me 15 minutes, and I'm going to take all 25 of them. So, a startling discovery, dawn of an era. A large broadband provider that is likely represented here today, and will get a t-shirt so he doesn't beat me up in the parking lot, deployed a bunch of Cayman broadband routers to their end users. And apparently they had some mix-up as they're going through the architecture discussions about what sort of passwords to put on these routers, and then how to manage that. Change every 30 days, what have you. So they came up with a brilliant solution. If you don't have a password, you never forget it. You don't have to change it. It's easy. My guess is it took the miscreants probably 15 minutes to discover this little feature. So they discover the Cayman router. They discover two things. One, no passwords. Two, no monitoring. They were owning these things on a massive scale, scanning like crazy for TCP/23. No one noticed. They get into these routers, and they find something really cool on them. Ping. It's kind of a neat tool. Lots of ping, not so neat. So they start writing scripts to manage several hundred or thousands of these to send a lot of packet love to him. You get a shirt, I picked on you. So they start to understand the power, and this is their term, bot power, of teamwork. Well, something interesting happened. This guy right here, I'll teach you not to pay attention, had 1,000 Caymans. This guy had 2. This guy talks smack to that guy, he packets him out of existence. That's not good. But he finds something out. This guy may have 1,000, he's got a pretty mad leet scan and exploit script, but he doesn't set a password. So let me introduce you to the free security service you're all getting. It's the Miscreant Security Service. He goes, jacks all of his Caymans, jack, steal, and sets a password on them. Of course, now the ISP's problems are solved too, right? So they go through, they're owning these, they're packeting, boom. But they have a problem. The Caymans were never designed to be war bots, and therefore, fortunately, and therefore ping themselves out, drop offline, are difficult to manage. What are you going to do? Next slide, please. You find Cisco. For those of you who would besmirch Cisco, let me tell you, a Cisco is a great packeting device. So the miscreants are out there scanning, and remember, they're scanning for TCP/23. And they're finding all kinds of stuff, right? Well, one miscreant finds he keeps seeing this certain prompt over and over. So he goes, he does a little digging, finds out, oh, it's a Cisco router. I wonder what password it has. CISCO. He's in. Well, that's pretty cool. And he can ping. That's even cooler. But then somebody says, oh, you can make configuration changes and stuff, but you have to have enable. Well, I wonder what the enable password is. Any guesses? Cisco. Great crowd. Great crowd. You get a shirt. So they find out that they can do extended ping from thousands of routers. So now it's not the little 64-byte packet love, hey, how's it going? Now it's thousands of devices sending really big packets to their friends and neighbors. So they start to write more scripts, more tools. Because one thing the underground is really good at doing is innovating. So if Dave here, member of Team Cymru, says, I would love to have 1,000 Cisco routers, but I don't know how to script, I don't know how to code. Not a problem. Place your order, Dave. Somebody will write the tool to make it easy. The first ubiquitously used tool was Cisco's .c. This is just a little C program that went out, scanned TCP/23, identified Cisco routers, and what did it do? Cisco, Cisco. If it works, save it off into a little file. Come back later for your viewing enjoyment. They were using what people started to call the default password. It wasn't a default password. It just turns out that that was the easy one that people like to use on a scale more massive than I ever thought possible. But then they figured a few things out beyond this. Yeah, I can send a lot of ICMP. Guess what else I can do? I can use a Cisco router as an IRC bounce. How many of you are familiar with IRC? How many would like it to go away forever? What a crowd, what a crowd. So they figured out that if they bounced through a router, they were no longer coming from their home machine. They're no longer coming through your machine that I hacked, which keeps going down because you keep patching it on me. This is quite a benefit. They found out that they could send spam through these routers. And so what I started to see in the public side were things like, I got spam from OC48- blah, blah, blah. Clearly, that's not true. Right? Proxies, all kinds of services, they just drove right through these routers. 2827. A miscreant who is a bot author wrote a bot called Cold Life. Anybody familiar with Cold Life? Heard me talk about it before? It's a variant of GT bot. It's a Windows bot. It's all written in Merck script. And he decided that he was going to get all these bots, and he did. He got tens of thousands of them. He included on every one of them a list of 2,827 compromised routers through which the bots would access the command and control channel. Clever. You find the command and control, what did you really bust? A list of routers. You call up the people who own those routers, what do you suppose the response is? Is that the big thing with blinky lights or the little thing with blinky lights? Right? So they were adding layers of obfuscation. In fact, when that bot kicked off an attack, it could do two attacks, one from the bots proper, the other from the Cisco routers. So you got this different type of attack from all these different sources. Next slide, please. So remember what I said about scripting and making life easier for the miscreants? So they put together nice GUI tools to help them scan and exploit. Right? That's a fairly intuitive one. I like that they put the Cisco logo on there. It's a source of pride. And they would just go through and own these things. And now, what's interesting about this tool and tools like it? Remember what I said about Cisco's.c? Scan TCP23, you're not Cisco. Oh, you are. Make a list. This tool's a little different. You're not a router. You are a router. Log into the router. Change the password on the router. Set some ACLs on the router. How many of you have ever ACLed yourself out of your own router? Look around. The people with their hands not up are lying. So the miscreants went through the same learning curve. Two miscreants jumped onto the same router. One miscreant had hacked it. Another miscreant was trying to mess with him a little bit. This miscreant hadn't set the password. But now it starts to turn ugly. It's an ownership thing, a pride thing. I'm kicking you off this router. But neither one of us have written ACLs before. And they're off. Eventually, one of them writes an ACL that blocks all TCP anywhere, everywhere. And of course, they're both off. Ha, ha, ha. Now, what's funny is you're picturing this small office. Click, 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 click. Not working. So they scripted this. Now anybody can download the tool, scan entire ranges. It took them, with this tool and a similar one, about 32 hours to scan an entire /8. Think about that. That may seem like a lot of time to us. But if all you're doing is hanging out in the bar all day, it's nice to know your machine is hard at work. They don't run this from just one machine. Next slide, please. So, oh, but Rob, I'm sure they only own those little frame FRAC-T routers, you know, with default routes and things. Sure. Lots of them. And these. This router was GSR, obviously. Hopefully you can read the text, so I've tried to expand it. And had 30-plus eBGP peers and was owned. So this miscreant hops in the channel and he says, hey, I just owned a router, my first one. So proud. What do I do with it? Well, some other miscreants are like, hey, download this tool, go get this web page, it'll tell you how to script your ACLs and stuff, you know, to block access. Okay. One of them says, what kind of router is it? You know, I don't really know. GSR. And if one can envision drool in an IRC channel, so you had two, there were several miscreants, but two, one saying, you don't want that router, it's really stinky. Why don't you give it to me, I'll take it off your hands. The other one, dude, you rock! So they're going through, this guy he has no clue, he doesn't know what the iOS is, so people are feeding him commands and stuff, and of course they're feeding him things like, oh, try no IP routing, and you know, all this stuff. That'll really scare it. And he makes an observation. Now remember, this is somebody who's never been on a router before in his life. This is somebody who's never run a routing protocol. He doesn't run an ISP. He says, hey, with all these BGP peers, can I reroute the internet? How's that for comfortable, warm feeling? Yeah, that kept me up all day. So they start to make these huge leaps, and they share far better than we share. They have no problem about sharing. Remember, they have hundreds of thousands of these. To lose 10,000 is, Another group of miscreants discovered routeviews, OregonIX.net. Where's Dave Meyer? Oh, Dave, you got a lot of packet love that month. Because the miscreants were just certain they had found the router that routed the internet. It's the mother load, man. So they're on this router, they're trying commands. What's that? Trying commands. Oh, Randy's speeding me up, you see how he is. And one of them makes the observation, dude, I don't have to packet you. I just have to get rid of your route. Creep, 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 right? Chill up the spine. Next slide, please. So they've got all these Ciscos. What the heck are they going to do with them? They're compromising them, and they're still doing this today. This hasn't changed, but we'll talk about the mode of changes. TCP 23, TCP 80. How many of you run the web server on the Cisco router? Yeah, I'm going to stick my hand up for that, Rob. T-shirt's cool, not that cool. So they're just scanning like crazy, stealing from each other, owning routers that come online, owning routers that get upgraded, new config. When they get in, they disable logging. These guys aren't stupid. You'll hear a lot from security experts. The miscreants are stupid, they're script kiddies, blah, blah, blah. Yeah, well, those 13-year-old kids are regularly owning BGP-speaking routers. Who's the dummy? They'll enable ACLs to make sure they're the only ones who can get in, right? Got to control your router. And, of course, they'll change or set the passwords. This could be stopped so very easily. What have I talked about? What have I said that was mad leak? Nothing. It's just simple people things. Next slide, please. So, as I said, routers are feature-rich, DDoS platforms, bounces for friends and bots, barter, love and war with routers. I watched one crew of about 35 miscreants go from 0% bouncing through routers to 80% bouncing through routers. That means they were all scanning, stealing from each other a lot. In one case, a miscreant hops on the channel. He's on a router. He's bragging about it. I'm on a router. How's it going? Bill Norton says, you're on one of those gay routers. You always pick the lame routers. I could take you down. Bring it on. Oh, no. Oh, bring it on. So he does. How do you know this? Because I see him ping timeout, right? He's gone. But then Bill goes away. I guess they packet each other. He comes back from a different IP. What's so funny? I was on his router. I was on his upstream router. He's probably still packing himself out of existence. So routers as attackers and victims. Prefixes. So the miscreants, it's not uncommon for them to be employed. It's not uncommon for them to make a little coin or barter. So they start hacking routers, and they're finding this thing called BGP. And by the way, you may have actually heard of this. There was supposedly a DOS tool called Big Gay Packets. Because a miscreant hopped on a channel and said, what's BGP? And of course, they always mess with each other. Big Gay Packets. And so I'm reading all these advisories from security experts. Fear big gay packets. I love the security industry. They're here for my amusement. So they're getting these routers, and all of a sudden, who starts talking to them? Spammers. You got a BGP speaking router? Yeah. Do me a favor. Announce this prefix. What does the spammer do? Listen to Nanog. Anyone complain? No? Thanks. Just that easy. But what have I done when I asked him to do that? Showed him the commands necessary to add a route into the global table. Suppose he kept that to himself? Next slide, please. Go, moving. Next slide. So, what motivates them? Quick question. Do you love your job?
Yes, I do.
Good. So you do it for no money?
Practically.
I had to pick the honest man. None of us are going to work for free, or very few of us anyway. Question. Why do you think the bad guys do? They don't. It used to be for pride, for barter, for status. Now it's for money. PayPal-driven, eBay-driven money. We have met the enemy, and they is us. In other words, they have the same motivations we have. They're in it for the cash. The cash and the satisfaction, of course. So, your routers are worth money. Your routers are worth money to spammers who will pay miscreants to do things with them, drive stuff through them. So as we talk to the brilliant guys up here, I'm just the raver, and they're telling you all the good things you can do on your routers. Keep in mind, do those things, but you're not solving the fundamental social problems. The spammers were paying the miscreants to DDoS, to spam, to announce prefixes, to hijack prefixes. A BGP speaking router is worth about 10 stolen credit cards right now. A non-BGP speaking router is worth 3 to 5. For those of you who's Juniper, your router's worth about 15. So keep in mind there's a value, an intrinsic value in what you have. What changed? The miscreants became the spammers. Or the DDoS attacks and all the anti-spam groups. Why did that happen? Money. Next slide, please. So, final thoughts. This will make Randy happy. There's a strong motive to compromise your routers. It's no longer pride. It's not status. It is money. There's a strong motive to hijack your prefixes. Spam, DDoS, scanning activity. All of that, if I can drive it off a prefix that doesn't belong to me, I avoid the pain. The simplest of best practices do help. There are advanced ways to hurt a router. That's not what they're using. Why aren't they using it? Because they're dumb? No. We don't make it necessary. They don't have to. Next slide, please. So, thank you, all of you, for your time. All of you who send me coffee, I love you dearly. Thanks to Randy, my lovely assistant. I'm Rob.
Not as entertaining as Rob, but for a government guy, you'll see I'm not too bad, okay? So this presentation is about approaches and techniques you can use today. These are things that are well documented out there. They're in the CIS benchmark. They're reflected in Team Cymru's templates. They're in the NSA router guide. They're in all those places, Tom Aiken's book, etc. As for me, I'm not really a part of this community. You don't know me. I've been working for NSA for 15 years, doing mostly network security related technologies. You can see on here I'm from the Information Assurance Directorate. That's the defense side of NSA. I don't do spooky spy stuff. I help defend US networks, okay? Just the way you guys help defend commercial networks, okay? Right, so my goal in this talk is to define a conceptual basis for router security and then give you examples of how some current techniques fit into that conceptual basis. And there's just an outline there, it's no big deal. I often get the question from my customers, well, I have these routers I want to secure, and I have all these books about how to do it, but which pieces are most important for me? And what I'm going to share with you is sort of the conceptual basis I try to tell them to help them decide what techniques they should employ. All right, so why should you do this? I mean, Rob has given you a great coverage of the threat. These hackers are out to take control of your networks previously so they could like trash talk each other, but now so that they can earn money from spammers and others. In the DoD, we have additional people that we worry about hurting our networks. Another good reason is to reduce downtime. You know, right? Your customers are counting on you to keep those networks up, to hide information about your networks. You don't, it's your network. You don't want someone else knowing how it runs and how it's built. To protect your customers and your clients and your partners, the people that you peer with. They don't want to be getting stuff through your link. And lastly, George said this bullet was corny, but to protect your country. The U.S. considers, and many other countries consider, the internet to be a critical national infrastructure resource. But it can't be protected by the government. It can only be protected by the people that run it. Okay. Security for a router or for any piece of a network infrastructure has to be driven by threat. If you don't know what it is you're trying to mitigate, how are you going to know how to secure it? Documented in policy. My favorite reason for this is if you don't have written down what your goals are, how are you going to know when you can go home finished? And if you were at Marike's tutorial yesterday, she emphasized this quite a bit also. And then you take those mitigations that you've documented in your policy, you implement them in the router configurations and in your network architecture. Then you maintain it with consistent procedures. Some colleagues of mine go out and actually look at DoD networks, and they often see that something may have been set up well, but then not maintained. And we all know how that goes. Things kind of drift. And lastly, you have to audit and test to make sure that you really did set it up the way you thought you did and that the security is really working the way you want it to. All right. So this is the obligatory cheesy animation. So you start with some threats, and you try to take those and find best practices or define local policies, and then you define security controls based on that. And first thing you need to do is protect physical integrity, then worry about protecting the static long-term configuration, then the dynamic state, and finally use those well-locked down devices to protect the rest of the network. And this is really the important piece I want to share, so let's talk about that just a smidge more. Physical integrity is very important because if anybody has physical access to your device, its security is not going to stand up very long. You know, we all know ways for doing password recovery and things like that. The long-term or static configuration is the long-term state the router holds all the time. Things like its config, the addresses on the interfaces, things of that nature. Who its log server is, who its AAA server is. Even if your router is physically locked in a closet and nobody can get to it, if they can change that information, your router will be owned, as Rob said. And that, a lot of what Rob was talking about was people attacking the static configuration. Who's my BGP peer? You know, what are the addresses? What ACLs do I have, right? Next is the dynamic state, and that's getting closer to changing things like routes. The dynamic state is the data of your router that changes over time. Locally stored logs, counters, traffic statistics, route tables, things like that. And then if you have a router or other network infrastructure device that protects its dynamic state, static configuration, and its physical integrity is protected, then you can depend on that device to help you enforce the security policies of the rest of your network, as we're going to see. If the static configuration is not protected, then you can't count on that device to, I don't know, filter out excess ICMPs or whatever else you're counting upon it to do. Okay. A lot of people like to talk about network stuff in terms of these three planes: management plane, control plane, data plane. So I just thought I'd give a brief mapping. This mapping is not exact, but it helps some people think about it. Okay. Now we're going to look at some typical policy elements, and I'm going to just rush a little bit to try to make up some time. These are some security goals, and we're going to look at them individually. Okay. So if you have a threat that's, who made these slides? Threats should be at the top. You start with the threats. So if your threat is login by hackers or unauthorized users, or inability to attribute actions to accountable individuals, if you were at the talks this morning, things like Rancid and Tool can help you keep administrators accountable for their actions. If your threat is that you won't be able to do those things, then what mechanisms should you use? Well, the good news is there are pretty good mechanisms on today's devices, at least the ones I've had opportunity to use, that can do this. You can have local username and password settings for every individual user, no shared accounts. Or, of course, you can use centralized AAA, which is a much better idea for scale. So if you have more than a couple devices, you'd want to go that way. Address-based filters, centralized cryptographic authentication are all a good idea. And that will mitigate largely or maybe even totally those threats. And that's technology you can use today. Okay. Another threat might be exposure of sensitive information to unauthorized listeners. If you're doing administration where your administrative session might go over untrusted links, for example, I'm sure at least someone in this room is logged into a piece of infrastructure device back at their office right now. All right, I'll try it. Yeah, anybody who's logged into a device back at their office, raise your hand. Oh, more than I thought. Cool. So, you know, this room probably is not a very well locked down network. You have hundreds of your peers are on this same wireless network with you, right? And so you should be using some mechanism that protects that traffic, keeps it confidential, protects its integrity. And the good news there is that a lot of devices have this already. Maybe not all, but most of them do. They have SSH servers. Many of them can support Kerberized Telnet. Some of them can support web admin over SSL. Personally, I've seen that more on VPN gateways and firewalls than I have on routers, but even some routers do it now. You could set up IPsec. That's a popular one in some places. Or if in a few places I've seen people set up separate back-end networks for this. Pretty rare, but it does get done. Okay, so that was the static config. Now let's talk about the dynamic state. Your threat might be exposure of your network architecture information to people who aren't allowed to know it. So you might require that only internal monitoring stations that are authorized collect information from your boxes. That seems pretty straightforward. And there are mechanisms, address-based filters, strong encryption on the management protocols, and IPsec that you can use. Now, that one's not quite as easy as it might sound. For example, your router might support SNMP v3, but if your management tools don't support it, the fact that the router supports it really doesn't help you. So this is starting almost to edge into George's territory, so I'm going to back off. Okay, next one. This is another one Marike mentioned quite a bit yesterday if you were at her tutorial. The threat is somebody giving you bogus routing information, right? And Randy mentioned this in one of his comments from the mics as well, that being important, that's a threat. So you want to try to accept routing updates. Maybe you say, okay, I'm going to mitigate this threat to my dynamic state by accepting routing updates only from interior routers and authorized partners. Well, that's getting a little difficult. There are some mechanisms out there for this, but they have glitches. You can use filters. You can use shared secret authentication. How many people are running, say, BGP? That's popular, right? You're all running that. Well, that has MD5-based authentication. So does OSPF. So does ISIS. So does EIGRP. And so does RIP version 2. So I think with that list, that covers most routing protocols. And another one that's sort of starting to get some adoption, I put it in gray, is the notion of doing routing updates over IPsec, a secured channel. Not really sure. I don't think that's getting much. Anybody actually doing that yet? Anybody out here? No. It's been talked about. Okay, protecting network traffic. So once you have your network infrastructure devices and that sort of infrastructure they represent locked down, you can use it to protect your network traffic. Maybe you have the threat of spoofed DDoS traffic exiting your network. That's kind of a no-brainer. So how do you handle that? You can use interface filters. You can use unicast RPF. You can use null routing of various kinds. Maintaining that can be difficult, so there are services that exist. In fact, Team Cymru runs a service. It's called Bogon Route Service. And you can connect to these services, and they'll help you null route that inappropriate traffic. Okay, a little trickier requirement. If you believe that a threat to your network is flooding attacks that use ICMP, you might set a requirement, well, ICMP can consume no more than 5% of the link bandwidth. Just a number I picked out of the air. Well, most modern routers have mechanisms that can do that. They're not usually very simple, but they're documented and they're out there. And you can take advantage of them to impose a mitigation. And then you got to try it, test it, see how well it works, and then maintain it over time. So I'm going to finish up now. There are a lot of resources out there. My personal feeling of having looked around is that there's probably more resources out there for Cisco right now than some of the other companies, but the resources are there for all the router manufacturers. Cisco ISP Essentials is a good one. Hardening Cisco Routers is a book I very much enjoyed. There's a lot of others. CIS Benchmark, there's the NSA Guide, there's all the resources at Team Cymru's site. Juniper has documentation. CIS will have a Juniper benchmark sometime soon. Foundry has a security guide, and the same is true of most of your other vendors. So use those resources, right? Take the concepts of what you want to protect, have those written down, then you can much more easily go to the vendor documentation or other resources and say, okay, now I know what I want to protect, and I can find the mechanisms, hopefully, to let me do it. Okay, and I'm going to hand over to George.
All right, thank you very much. All right, we're back. Very good. Well, thank you both. First of all, right, will do. So first of all, I'd like to thank Randy for inviting me to give this talk, and thank you all for coming.
I thank Randy too.
Yes, we're going to change the. We'll just go with this.
Here, just do it once, twice more, and you get it.
Yeah.
Just wait.
I'll just do it this way. No, it's fine. It's fine. I'm fine. So anyway, my name, as has been said, is George Jones. I'm currently working for MITRE Corporation. Until earlier this year, I spent about 3 years working at UUNet, and there my main thing was infrastructure security of the web hosting data centers. So at that point, I was dealing with something like 22 data centers, about 450 routers and switches and that sort of thing. And so, that's how I got to be thinking about these sorts of things. One of the things I did in that role was when vendor X would bring in a new box, it would go over to the engineering people and they would see, can it do throughput? Does BGP work? Then it would come over to the security side, and we would say, here's the list of things that we want to be able to do. If we're going to take this box and put it on a network and operate it in what we consider to be a secure fashion, this is the list that we're going to use. And so that's really where this work came from. And our idea was it would be a good idea just to get some public feedback and see if other people had the same goals. The draft is up there. You can go take a look at that and review that. And let's see. Right, and so what we're talking about, the title, what we're talking about is basically, the settings. What controls do you need? Do you need logging? Do you need authentication? What do you need to be able to put it into the network and run it securely? The now and then portion, and we'll talk about this in a little bit later, but the now is basically the things that if somebody tried to sell you a box today, that didn't have, logging or something, you would tell them to go home. The then is the things that, you wish the vendors would do. Maybe some of them are doing it, maybe none of them are doing it. So that's sort of the breakdown of what we've got. And this is why I wanted to do it. Okay. All right, so I'm going to touch just for one slide here on sort of what the stuff that Rob was going on. The question, what this is really about is, will I continue to own my router, right? I want to show of hands here. How many people have been in the middle of tracking an attack or something, and you've written an access control list, and you're just about ready to hit the return button, and then all of a sudden the fear grips you. Is this going to drive the route processor through the roof, and am I going to lose my router when I hit the return to apply this access list? How many people have been in that situation? Okay, very good. How many people have ever worried, or how many people, we'll do the inverse on this one. How many people have not worried about things, about script kiddies taking your router down, about the latest, single packet jams the input queue, about, the SNMP being able to, take your router down? How many people have never worried about that? Okay, so I think it's fair to say that script kiddies not taking down your router is sort of something we'd like to be a requirement. And then this one's rhetorical. How many people think that in 2003 that using protocols for management of critical infrastructure devices which use either plain text passwords or in the case of say TFTP no passwords is kind of a bad idea and that we ought to be beyond that. That's more or less rhetorical. All right. So, to solve this problem, there's really sort of two things you can do. One is you can continue to muddle through and do things and fight fires and, just sort of make do with whatever the vendors, throw over the wall at you. And the other thing you can do is ask the vendors for better features, and that's sort of what this talk is about, is about, hopefully the NSP, the ISP communities coming together and saying, this is what we want. To the credit of Cisco and Juniper and, the other vendors, a lot of them are spending a lot of cycles on this, hiring people like Rob, and they're doing a very good job, and I commend them for what they're doing. But, I think there is a place for the operator community to come together and say, look, here's our requirements, and then we get together and talk. So that's mostly what this is about. And just to reiterate, the goal, what we're talking about here is not sort of firewalls. We're not talking about intrusion detection, anti-spam. We're not talking about stuff on the desktop. We're talking about how to keep your networks running, how to keep them passing customer traffic, how to keep them from, people from violating your AUPs, that sort of thing. All right. So next thing I'm going to do is just in one slide, I'm going to give you sort of an overview of the draft and just to give you an idea of what's in it. Then following this, time permitting, I've got 4 examples of stuff in the now category and 4 examples of stuff in the then category, and so we'll just go through some of these. But this is just to give you an idea of what's in here. And what I'm really after in this whole talk is for people to start thinking about this and sending in feedback, because I can't do this alone. It's sort of you guys have to give the input. All right, so the 01 draft, what's in it? We've got functional requirements, which is the lion's share of them. We've got documentation and assurance requirements. And then the last thing is we've got profiles. So I'll just take a quick spin through functional to give you an idea what's in them. So for instance, device management. Device management, you would like, as Neal sort of alluded to, you'd like to be able to say that, I can securely manage my device, and we'll take a look at that in a little bit. You would like to possibly be able to manage it in band, because in most situations, a lot of situations, all you have is the same connection that the customer data goes over. So you'd like to be able to manage that way. Out of band, if you happen to have an overlay IP network, or you happen to have a modem hung off the side of the thing, you'd like to be able to manage that way. User interface, is it acceptable to have a high bandwidth graphical, Windows-based interface to manage a box in a situation where you can't get to it through the front end and all you have is a modem? Can you really do the screen updates, over a modem? So that's sort of user interface sorts of things. Or do you really want a command line interface? I mean, that's one question. IP stack, do you want to be able to do things like turn off directed broadcasts or IP options? It's things in that class. Is it acceptable to have a single packet, jam your router? Just things in that nature, just things related to the IP stack. Rate limiting, as Neal alluded to, it's often a very useful tool for making sure that your router's not doing really insane things. And then the next 3 are filtering capabilities. These are sort of a large part of the draft. At a minimum, you would like to be able to say that, only, say, my SNMP management stations can talk to my box via SNMP. Only, only hosts in my well-defined management network can talk to my box. So that's filtering directly to the box. This is just sort of giving you highlights of the areas, and there's a whole bunch more. Event logging, right? You'd like to be able to log. You'd like to know when things are happening on your box. You'd like to have a record of it so you can do forensics and operational response, that sort of thing. AAA, if somebody comes to you with a box today that has, I think as sort of Rob alluded, a default password or no password, or, you can go to Google and type in, default password, router X, that's a bad thing. Try it sometime. No, never mind. Don't try it. Documentation requirements. This is things like, what protocols does this box implement? What ports is it listening to by default? What is on this box? What is the exposure? Assurance. This is things like, and we'll get into this one in detail, but what assurance do I have that the box is not going to fall down? Right? It's not a functional requirement, but how do I know that maybe the vendor is going to be responsive and give me patches and updates when I need them? How do I know that? And then lastly, profiles. We make the admission that not all devices are created equal. You've got core devices, you've got edge devices, you've got layer 2 devices, you've got layer 3 devices, and so profiles are just a mechanism for grouping sets of requirements that apply to different classes of devices. So that in one slide is the overview of the draft. It's just sort of a skeleton and a way to plug in requirements. Okay, let's see. Right. So examples. Now we'll go into some examples and just take a look at this. So the first one is secure management channels. Again, I've sort of already talked about this. You would like to be able to manage end-to-end. In a lot of cases today, that's going to be SSH or TLS or IPsec or something. You want to know that nobody's seeing your management traffic, that nobody is injecting interesting little commands into your command stream. And you might want to, for instance, hide the identity of your management stations. There's just all kinds of things. You would like secure end-to-end management, be that in-band or out-of-band. Okay. Right, I mentioned this one already, the ability to identify all listening services. You want to know what's there. You want to know what your exposure is. And right, so what this comes down to is, to take the analogy of a house, right? If you have a house with no windows, right, nobody's going to come climbing in through the windows. If you have a network with no windows, nobody's going to have, no, never mind, viruses. Okay, but the point is reduce your exposure. So this is identifying all listening services. The corollary is the ability to disable all listening services. So you want to be able to go, if you're not going to use Telnet for management, you would like the ability to go in and turn it off. What I'm saying in this is it's a requirement that, you know what everything is and you be able to turn it off. Excuse me? Right. Yeah, if you want to send in, for instance, requirements, do it. Send them to me. Send them to the list. This is just a sample here to show you what sorts of things are in the draft. Okay. We're doing good. All right. Right. So I've already mentioned this. You would like to be able to filter traffic directed to the device, and again, this is just so you know who's managing your device. Know that it's hopefully you that's managing your device. As I think Rob already sort of talked about miscreants, making sure that only they can manage the device. Right. So that sort of ends the examples of the now. Those sorts of things that you would hopefully beat on people if they tried to sell you a box that didn't do them. In going through this process, it's been sort of amusing to me which items drew flack. And so some of these I originally had in the now portion, and they've moved to the then portion. The ability to filter at line rate. If you can apply access control lists, to the box that allow only authorized traffic to it, but somebody can flood you and take the box off the network, it's not really useful. And so, this is sort of obviously an idealized state, but you would like to be able to filter. If you can apply filters, you'd like to be able, ideally, to apply them and filter at line rate on all interfaces simultaneously. And this may be a tall requirement. This is probably going to imply ASIC hardware implementations, but I think it's a very reasonable thing from an operator's requirement point of view to ask for. All right. This one actually is the one that surprised me the most that I got feedback on. The the basic idea here is that, you know, hacker X should not be able to go to nessus.org, download Nessus, you know, with all the fun router plugins or whatever, aim it at your box and get results, right? You know, you shouldn't be able to go out and look at cert advisories and try one that's 3 years old and you know, try the exploit for the vulnerability that's 3 years old and be able to take the router down. You know, this is just you know, simple sorts of things. You know, but I've gotten, this is one I've gotten a bit of pushback from the vendor community, and I've come to understand why. Let me just run through this. The requirement is worded very carefully, and the problem really is in getting a definition that everybody can agree on. So I'll just sort of read it here and then go through it. So the vendor should provide software updates or configuration advice in a timely fashion. There's one problem. To mitigate the effects of, quote, well-known vulnerabilities, unquote, and vulnerabilities and well-known, quote, should be, quote, exploits, unquote. So the problem really here is all in defining these terms and agreeing on what these terms mean. So, you know, what is in a timely fashion? If I'm a network operator and somebody takes my network down, the advice and configuration stuff was not provided in a timely fashion, right? I want it before it takes my network down. If I'm a vendor, on the other hand, you know, I've got development cycles, I've got product cycles, I've got priority, I've got revenue streams, and that sort of thing. So, you know, there are competing, you know, priorities as far as what is timely. You know, well known. Again, if I'm taking an absolutist operator's point of view, well known means it got used against me. You know, I think sort of the low bar here might be, you know, for instance, cert advisories, because those tend to come out, you know, sort of infrequently and be only the really wide impact things. You know, you could move out to my buddies at MITRE over at the that do the CVE stuff and say that, you know, things that are in the CVE database, you know, would be the next realm out. You could say, you know, Nessus plugins, whatever. If somebody can take a Nessus plugin and, you know, but the question really is what's well known. And right, so that's pretty much that. But, you know, just, you know, from a gut level, I don't think it's too much to ask that people not be able to you know, knock down the boxes that I've paid a lot of money for. Okay, that'll be done. All right, so here's one that's somewhat of a conundrum. We would like to be able to select reliable delivery for log messages. In this case, there's already an RFC out there that defines exactly what we want. You know, we want to be able to send messages reliably, and RFC 3195 does a very good job of specifying that. The problem here is that the implementations, you know, both in the router side and then on the log server side just aren't there. So it's not one that we can say is best current practice, but the standards are there. So that's sort of a conundrum. So that's why it moved over. The ability to log all security-related events. You know, so for instance, when somebody logs into a router, or logs in, logs out, when somebody violates an access control list, when somebody makes a configuration change, these are all things that you want to know about. Problem here is, as far as I know, there is no well-defined set of things that say, you know, these sorts of things should be logged. So this is an area where, you know, it's possible we might want to get a working group or something going just to define, you know, a minimum set of things that ought to be logged security-wise. Support scripting of all management functions. So, okay, operator question again. For operators, how many of you believe that the vendor is going to provide functions to do everything you need? Okay. How many, okay, vendor show of hands, how many believe that you can foresee all the problems involved in managing large network or responding quickly to problems? Okay, no show of hands. Our experience at UUNet when I was there was that, you know, we have large networks and we just have to be able to roll custom scripts to take care of the problems in our own network. And that's really all this requirement is saying is you know, give us that capability. And I'll wrap up here. Right, so I'm going to skip all the details, go read the draft, right, and we'll go back. I love XPDF as a presentation format. All right, so what, you know, I'm just going to come back to sort of where I started here. You know, your choice as sort of the operator community is to either keep doing what you've been doing, you know, muddle through, fight the fires, and hope that, you know, Cisco and Juniper and crew throw things over the wall that you can use. Or, you know, your choice is to get together and sort of, you know, help define the operator-centric set of requirements that you need to operate your network securely. Okay. How you can help, sort of two ways. If you want to help, take 5 minutes and write 2 lists for me. One is the security features that I use now, right? What do you use in your network every day that you would consider a security feature? Send it to me, send it to the list, the address will come up shortly. The other is the things that either one vendor does that I really like and I wish were everywhere, or it could just be pie in the sky sorts of things. You know, what sort of things in an ideal world what security features would you have in your routers and switches? All right. And so here's the contact information, whatever, if you want to send stuff in. Unfortunately, we've got a deadline coming up Monday, so anything you send me has to come quickly if it's going to make the next draft. There's a mailing list. There is a Unix-centric way of subscribing to the mailing list that Randy so kindly hosts for me. And there's archives of the mailing lists, and OPSEC comment is one way to send it in, or you can just send it to me because it's basically me. The draft is up there. That would be the draft to comment on right now. It will probably, by the time IETF rolls around, be 2 drafts split into sort of the info and the BCP. The BCP being the now, the info being the future. And at this point, I think we're right up on time. So I'll leave it to the moderators as to whether we have questions, you know, war stories or wild rantings from the audience. So thank you very much.
About to say?
That we have time for questions if you'd like.
Yeah, I mean, a couple questions, but my big thing is I hope this session has kind of tried to move the ball a little forward on what you can do about a little better practices and what we all can do about trying to get the tools we need from the vendors. There was a tutorial yesterday about essentially what Neal was talking about is best practices for securing. How many people here find that sufficient, or they'd also like to have, instead of just a tutorial, actual hands-on workshop? Will that help? What will help you get better practices in your environment before you get killed? Any suggestions what we at Nanog can do to help move this along?
One thing that I find...
What's your name,
Michael
Michael?
Dillon, Radiance. One thing that I find very useful when trying to explain these things to people, why things are needed, why things need to be done, and how they should be done, is to have a clear and detailed example, more or less along the lines of a case study to point people to. Because, you know, people don't necessarily trust me when I say, we should do this. If you point them to information sources outside, things on the web and so on, they're not always all that well organized and clear and step by step for, you know, people who... What you're really doing is you're taking people who aren't concerned about an issue, trying to get them to understand the issue and become concerned about it, and also see a light at the end of the tunnel that there are actually things that they can do that will make things better.
So how I went to town and got mugged, and what I did next time to go to town to prevent from being mugged.
Yes, essentially, in a case study of an actual ISP that shows that type of thing.
Point taken. Thanks to the party.